In this video, we are going to talk about relational operators in Java. So here are the relational operators, and these work pretty much the same as they do in math class. A couple of things to be aware of that are different. First off, if I have two things and I want to compare them, to see if they are equal to each other, it's double equals as opposed to single equals. In Java, right, the single equals is the assignment operator that is used to store values in variables. So if you have two variables and you want to test to see if they are equal to each other, you have to remember that it is double equals, okay? Then x is not equal to is an exclamation point followed by an equal sign that will test to see whether two values are not equal to each other. And then I have greater than, less than, greater than or equal to, and less than or equal to. All of these are very similar to how they work in math class. So when you use one of these relational operators to compare two values, you will get either a true or a false as the result of that comparison. Okay, so that type of expression is called a Boolean expression. Now, sometimes you'll hear people call it a condition. It just kind of depends. But that is something that evaluates to either true or false. All right, let's take a look and see how these things work in code. So here I have a class relational operators example, and what I do is I just compare values using the relational operators, and then I encase those comparisons in system.out.println so you will see the result. So I'm just printing out those, and so you will see a bunch of trues or falses printed out here. All right, that's pretty much it. Okay. All right, so let's take a look at the first set here. In the first set, I'm doing system.out.println, and I am comparing, these are ints in this case. So I have 5 is equal to 3, and that gives me a false here. 5 is not equal to 3, that's true. 5 is greater than 3, that's true. And so on and so forth. So here you can see I can compare literal int values. In lines 13 and 14, I declare two int variables, and then I do some comparisons. So they're both have the value 9, num1 and num2, and I really should have put some breaks in here. So let me add that in there so we can see where that starts at instead of having to count down. Okay. Well, I guess it was kind of obvious, but anyway. All right, so here I have num1 equals num2, and since they both have a value for 9, I get a true. Num1 is not equal to num2, I get this false, right? And then greater than, I get a false. Less than, I get a false. And then I get these two trues right here because 9 is greater than or equal to 9 and it's less than or equal to 9. In this example here, I have an example of automatic type promotion. 17 is an int and 8.6 is a double. So you can compare different numeric types and it will automatically promote those types according to the rules. Very similar to automatic type promotion when we're talking about arithmetic between different types. Okay, that will only go so far though. If you notice this very last line here that's commented out, if I try to compare here an int 5 with the string 5, Java's not going to be able to make that comparison. Right? It'll say bad operand types for binary operator double equals. So in other words, Java is not going to compare the int 5 with the string containing the character 5. Okay, so you can only go so far. Java can only figure out so much there. So you're not going to be able to compare strings with numeric types unless you do some kind of conversion. All right. So that's the basics of the relational operators. There are a couple of things I need to warn you about. Number one is don't compare doubles with double equals. It's not reliable. It'll work sometimes, but sometimes it will not work. Okay, so let's take a look at that example comparing doubles. All right, so in comparing doubles, what I do is I define a variable number of type double, all right, and then I have this subtraction value over here, 2.2 minus 2.0, okay? That is going to come out to be 0.2, okay? When you do that. All right, and then in line 20, I do this comparison. I compare the value of number to 0.2 with using double equals, so 100%, right, should be true. Because 2.2 minus 2.0 comes out to be exactly 0.2. All right, so compile this and run it, and you're going to see that the answer is false. Right, and so you're like, wait a second, that's not right at all, right? This is exactly 0.2, and so this should come out to be a true. Instead, I get a false, okay? The question then is, why am I getting that false? And in the next line, you can see the issue, right? When I go to print out the value of number, which I do here in line 26, right? I get 0.2 and then a bunch of zeros and then a 1.8 on the end. So this little 1.8 on the end was what caused the problems, okay? There was a little round off error in this calculation of this 2.2 minus 2.0, okay? So now the question is, all right, where did that little round off error come from? Well, if you remember, right, everything has to be inside the computer, has to be encoded as a bunch of zeros and ones. And if you have a 64-bit computer, let's say, then you have 64 zeros and ones to work with. And that's a lot. You can write a lot of numbers, right, decimal numbers, as a sequence of zeros and ones. But even though you can write a lot of them, it's still only a finite amount, right? Even though it's a very large number, that means that there are infinitely many numbers that you cannot write exactly as a sequence of zeros and ones in the computer. So what ends up happening is that, and sometimes when a computer will do some arithmetic operation like that, it will come up as one of those numbers that the computer cannot express, right? And therefore you will get this little round off error, okay? So you could try to add more bits, but that's still not going to fix the problem, right? 128 bits or 256 bits, yeah, you will be able to represent a lot more numbers that way, but there will still be infinitely many in which you cannot, and so you still will have this issue with a data type like double, okay? So it's just inherent in there. So you just have to know, hey, this is not reliable when I do this kind of comparison. In the rest of this, I show you some ways to do that, to make those comparisons. One way to do it is to say, hey, well, if the double value I get is close enough, if it agrees in this many 4 decimal places, then we'll say it's equal, okay? And so here you can see that's the result of that comparison. You can see that this number 0.2 is very, very close to 0.2, right? It agrees in a lot of decimal places. So one of the ways in which you could say 2 doubles are equal is if they're agree to, 5, 6, 7, however many decimal places, okay? The other way is a built-in class called big decimal, okay? And I'm not going to go into the mechanics of how you do this. Here, I basically do the same things that I'm doing up here. Subtract 2.2 minus 2.0, and then I do the comparison, okay, and printed out the number. You can see it's a lot more verbose, right? It takes a lot more writing to do that, so big decimal is more complicated. It will also take up more memory to do it this way. But in certain industries, you have to be very, very exact about numbers, and so that's the way. One of the ways in which you could be more exact. And you can see in this case, when I print out the value of that, you get 0.2. So you don't really need to know about this stuff exactly. If you go on into numerical analysis, you might see some algorithms for terminating that looks like this, and maybe in the financial industry or something, you might see something that looks like this. For right now, just worry about the fact that comparing to double values with double equals is not reliable. It's going to work okay sometimes. Sometimes it will not work the way you think it will work. Okay, so don't do it. All right, the other thing that you cannot use double equals to compare are two strings. Again, it will work sometimes. Sometimes it will not work. So let's take a look at this example comparing strings.java. All right, so here I have a variable, var1. I get the user to type some information in a dialog box from the option pane. Here I define another variable called var2, and I put the string whatever in there. And then in this line 21, I ask the program to compare what the user typed in with the string whatever to see what I get. Okay. All right, so let's run this. Also here I compare the value of var1 and var2, which is this variable that I declared here. All right. So I'm going to compile this. All right, in the dialog box, I am going to type dog and press enter. Now you can see I get 3 falses here. Okay. And that's as it should be. I typed in dog. It's certainly not equal to whatever. So I should get a false here, and then I'll show you what the last one is in a minute. All right. So the weird behavior is when I run this, and I'm very careful to type in whatever, WHATEVER, and click OK. And you can see I get false here, right, on the first comparison. All right, that is totally and completely unexpected. Okay, that should come out to be a true. I typed exactly whatever. Okay, and so I should have gotten a true there. I typed in whatever, and I should have gotten exactly a true here as well, because what I typed in for var1 was exactly the same what that was in var2. So that's the take home here is comparing two strings with double equals is not reliable. All right, so the solution to that is to use the dot equals method. If I do var1 dot equals and then var2, you can see I get the true comparison, which I should get. So you should use dot equals to compare two strings. That's the only reliable way to do that. Why does double equals, the comparison with double equals, not work? The reason it doesn't work is because when you use double equals, and now you had to have watched from chapter 6, right? There was a video that I put out about the way reference types are stored as compared to primitive types. Okay, so when you strings, right, are stored as references. So in these variables var1 and var2, okay, what happens is that there are two different references that you get. Okay, so the reference here is not equal to the reference there. In other words, these two values of whatever are stored at different references. So when you use double equals to compare them, it only compares the references. It's kind of like you have two lockers, and there's like let's say a book that's exactly the same. One copy in one locker, one copy's in the other locker. So when you ask to compare these two values here, var1 and var2, it's like saying, well, they're in two different lockers, so they can't possibly be equal without going in. It can't be the same book in both lockers. since they're in different lockers. Okay, so it only compares what's actually stored in the variables. Whereas here, when you do var1 dot equals var2, it's like actually going into the locker, pulling out the book and looking at it, right, and then going to the other locker and pulling out the book and saying, oh yeah, hey, what do you know? They are equal to each other. So it actually compares. In this case, it only compares the memory addresses, and if they're different, it's going to say no, they're not true. Whereas when you do dot equals, it will actually go to those memory addresses and look at the string values in there and do the comparison. So that's why we get the true. Okay. So again, the take home here is whenever you're comparing two strings, use dot equals. Okay. All right. I think that is it for these relational operators.